This is the full system setup for optimized device measurement and analysis. This is our device, which is specially configured for biosensing in liquid environment. And this is the user interface. It's actually a measurement and diagnose system rather than only a user interface. And this is the network analyzer, which is the backstage for the measurement. Now, if we switch on the program, you can see the computer start to communicate with the network analyzer. Okay, you need to wait for the data acquisition initialized. Okay, it's got all the data here. Okay, from the backstage, we can see the network analyzer controlled by the computer automatically measured the transmission coefficient and also the reflection coefficient. And the computer control it to automatic track every resonance peak. For example, in this window, this is mainly for the low wave resonance. It's almost or always tracked this low wave resonance for the amplitude change and the phase change. And in the reflection coefficient, we use the third order for the temperature composition. So it both tracked the first order low wave resonance and the third order low wave resonance. And on the computer side, you can switch off the function modular separately. Here, for example, if I switch on the device surface coverage analysis switch, okay, I switch this on. You can see there's another measurement engaged, which is measure the first order relay wave transmission coefficient amplitude change. And then it can deliver the data to the computer to analyze the surface condition of the guiding layer. Now let me give a very brief introduction of the user interface. Here, in this section, it's the data acquisition window, which we can monitor the data acquisition, and also it automatically do the data fitting. You can see here's the data fitting. We use the mathematic method, which is polynomial data fitting method, to automatically analyze the condition at the tip of the resonance peak. You can see it's the red lines is automatically simulation the resonance peak. The benefit from this is if there's any sudden signal change, if there's some like radio frequency signal interfere, and if there's some dust suddenly attached onto the surface, but which is not the signal we need to measure. Then if there's some weird change or the date samples, it will automatically average it and keep the resonance peak stable, and give a more trustable analysis. And also from this modular, we can switch on and switch off the data fitting, data saving to the local computer, and control the different display, and give the detailed analysis for the both frequency drift and for example here, the phase drift, and also we can manually measure the quality effect of the device, which is for diagnose the device quality. So this is for the data fitting and the data acquisition and the data monitoring. And also the second part in the middle here, this is for directly control the network analyzer to make the network analyzer can automatically adapt to different devices. For example, the frequency swap range and the frequency date fitting algorithm, and also the bandwidth of the network analyzer, which is directly related to the hardware performance of the network analyzer. If we set it properly here, actually for the different devices, we don't need to do any manual setting. Whole system will automatically adapt to the device, then make the measurement much easier.